Hey guys, welcome to week number 2 of the ACE or IB math exams in 10 weeks. If you didn't watch it yet, if you didn't go through the exercise list yet, week number 1 was already posted, of course, and you can find the links for both the video and the exercise list from week number 1 in the description of this video. I'm Bruno, the IB math teacher. If you do not know me, I've worked as the HL math teacher in one of the most prestigious IB schools in Brazil, and I've also worked as an IB math examiner. And for this May 2026 cohort, I've decided to launch a 10-week series with carefully crafted, challenging IB style math questions from paper 1 and paper 2 to better prepare you for the upcoming IB math exam. You can download the exercise list in the description of this video. The link is there. Do know that each list is composed of 5 different exercises, one from each topic: number and algebra, there's functions, trig, probability and statistics, and then lastly calculus. And do also share this link to this PDF and also the YouTube video with your friends so you guys can practice together. By the way, studying by yourself is not as fun as studying with your colleagues, so maybe that's a good idea. Now, let's tackle week number 2 in this 10-week series, ACE or IB math exams in 10 weeks. Let's get to it. All right, so let's start with, of course, exercise number 1, a proof by contradiction. What a good start. But question A is quite easy. It's the "are you breathing" type of exercise. Question A asks you to show that x cubed plus y cubed is equal to x plus y times x squared minus xy plus y squared. Now in this case, it is much easier to start from the right hand side and work your way towards the left hand side than the other way around. And that's what we're going to do. On the right hand side, we have x plus y, x squared minus xy plus y squared. Now we are going to FOIL it or use the distributive property to expand this product of terms, which will give us x cubed minus x squared y plus xy squared plus x squared y minus xy squared plus y cubed. We can see that we can simplify 4 of these terms, giving us precisely what we see on the left hand side. So this is equal to LHS. Therefore, it is shown. Now, notice that on question B, you have a hence or otherwise, meaning you might or might not use what you got in question A inside question B. It's up to you. Prove by contradiction that for all positive real numbers a and b, a cubed plus b cubed is greater than or equal to a squared b plus a b squared. Now, how does a proof by contradiction work? Proofs by contradiction, they are a 5-step process. Step number 1, you are going to state the proposition, meaning what you're trying to prove. A cubed plus b cubed is greater than or equal to a squared b plus a b squared. So you're pretty much just copying the description of the exercise. And by the way, this means positive real numbers. Step number 2, we are going to assume that not P is true. What is not P? It's the negation of P. Negation is a better word compared to the opposite, but you can think about that as being the opposite as well. Think about what is the opposite or the negation of a cubed plus b cubed being greater than or equal to a squared b plus a b squared. Now the negation of that is a cubed plus b cubed is less than a squared b plus a b squared. By the way, other ways that you can write not p are like this. This means not p, or you can just simply write not p. So these 3 are equivalent. Obviously, you do have to state what is not P. Not P is this. Step number 3, which is to develop the proof. This is the next step. What we're going to do here, we're going to manipulate this expression algebraically. And you notice that in the end, we're going to get something that's simply not true. Now, remember this. You should get something which is false, not because you made an algebraic error, not because you messed up the signs, something like that, okay? You are going to arrive at a false statement or a false equation or a false inequality because your process was correct, but the initial assumption was wrong. Therefore, towards the end, we're going to say, okay, so we cannot assume that not P is true. Therefore, P is true. And then we're going to end the proof by contradiction there. But let's cross that bridge once we get to it. How can we manipulate this inequality? We should start with not p. And in this case, I'm gonna move the two terms from the right to the left-hand side, or subtract a squared b plus ab squared from both sides. So this is what we have, less than 0. Now, from question A, and this is where the hence comes into play, I'm going to rewrite a cubed plus b cubed as a plus b, a squared, minus ab plus b squared. So there we go. And also, from these two terms, we can factor out a negative ab, meaning that we're going to get negative ab over here times a plus b. And we can just copy this portion right here. Now, what else can we do over here? We can factor out an a plus b from each of these terms. So we're going to get a squared minus a b plus b squared, which, by the way, comes from here, minus ab, which comes from here. And this, according to our assumption, should be less than 0. Now, notice that this is a squared minus 2ab plus b squared, which, by the way, is the same as a minus b squared. Now, this is exactly where the contradiction lies, which, by the way, is the fourth step in any proof by contradiction, which is to identify the contradiction. And now we write which is a contradiction. Now, you might be wondering, okay, but where's the contradiction? And we do have to explain where the contradiction lies. A and b, they're positive real numbers, which means that a plus b is positive, and a minus b, it doesn't matter if b is greater than a. If it's squared, if this difference is squared, this is also greater than 0. Therefore, the product a plus b times a minus b squared cannot be smaller than 0. And you might say, what if a and b are equal? Let's say a is 2 and b is 2 as well. Well, in that case, we are going to have a product between 4 and 0. This is going to be 0. 0 is not less than 0, so still it holds. So let me just write step number 4 over here. And by the way, you don't need to write steps 1, 2, 3, and 4, and 5 in your exam. You just need to go through the process. But step number 4 is to identify the contradiction. And what is the last step? Well, let me write it up here because I don't have any more space. It is to write the conclusion, which pretty much means that by contradiction, we can affirm that P is true. And that's it for exercise number 1. All right, so let's get to exercise number 2, an exercise which is not trivial at all. This is not the typical inverse function exercise that you find in simpler questions. This actually involves a couple of steps. Now, we were given the inverse of f of x plus 2, and it is equal to 3x minus 2 over 2x plus 3, a rational function. We need to find f of 1 over x minus 4. The problem is we don't have f of x. We don't have f negative 1 of x. We don't have the inverse of f of x. We have the inverse of f of x plus 2. We need to deal with that first. And how do we do that? We can use a substitution. We can replace x plus 2 by u, because if we find the inverse of f of u, we're pretty much finding the inverse of f of x, because u or x, these are just names of variables. Whatever we get over here will be almost identical to f negative 1 of x. We just need to change the variable from u to x. Now, if we're calling x plus 2 u, that means that x is u minus 2. Therefore, on the left-hand side, we have f negative 1 of u. On the right-hand side, we're going to replace all the x values by u minus 2. So we have 3 u minus 2 over 2 times u minus 2 plus 3, which gives us 3u minus 8 over 2u minus 1. Therefore, the inverse of f of x is 3x minus 8 over 2x minus 1. Now, given that we have the inverse, we can now find f of x. We're going to call f negative 1 y at first, and this is the process for finding inverse functions. Then we replace the y by x and all the x's by y. And just to restate this, we're finding the inverse of the inverse, which means that we're going to find the actual function f of x. And then we manipulate this equation in order to isolate y. In this case, we're going to cross multiply the 2y minus 1 to the left-hand side, which gives us 2xy minus x. 2xy minus 3y equals x minus 8. We're going to factor out the y on the left-hand side, which is going to give us y times 2x minus 3 equal to x minus 8. And by dividing both sides by 2x minus 3, we get x minus 8 over 2x minus 3. Now, this is the last step, and by the way, just to restate, this is the inverse of the inverse, which means f of x. We get x minus 8 over 2x minus 3 as our f of x. Are we done? Not quite, but almost. Given that we have f of x now, we can indeed find f of 1 over x minus 4 by replacing every x value by 1 over x minus 4. So again, given that f of x is x minus 8 over 2x minus 3, or f of x, or actually our f of 1 over x minus 4, it is equal to 1 over x minus 4 minus 8 over 2 times 1 over x minus 4 minus 3. We can multiply the numerator and denominator by x minus 4 without compromising the function. We still have the same function, and this gives us 1 minus 8 times x minus 4 over 2 minus 3 x minus 4. And finally, we get our final answer, which is negative 8x plus 33 over negative 3x plus 14. If you want to write this with the coefficients of x all positive, you can multiply the numerator and denominator by negative 1, which of course is the same solution. So 8x minus 33 over 3x minus 14. All right, exercise number 3. By using the trig identity, cosine of a minus b equals cos of a, cos of b plus sine of a, sine of b, show that the cosine of 180 minus theta is equal to negative cosine of theta. Now, this is an identity that we use a lot in the HL course, and we're proving not the identity itself, but the fact that the cosine of 180 minus theta is equal to negative cosine of theta at this moment. So let's get to it. All right, so it's pretty evident that we're calling 180 degrees A and theta capital B. Therefore, we have cosine of 180 minus theta as cos of 180, cos of theta minus sine of 180 degrees times sine of theta. And knowing that cosine of 180 is equal to negative 1 and sine of 180 is equal to 0, well, we are pretty much done. Negative cosine of theta. And that's all there is to it. Now let's jump to question B, which is the most intricate one. In triangle ABC, a line segment connects point A with the midpoint of BC, meaning that this is equal to this. Given that AB is equal to 8, AM is 5, and AC is 6, and by using what we got from question A, we need to prove, or actually to find, these segments BC. And how do we do that? The first thing you need to realize is that this is equal to this, so let's just call it X, because, well, why not? The way that it is pointing us to using the cosine rule in some way, but we're missing angles. It's not like we can apply it right off the bat. However, if you take into account the fact that the sum of these two angles, this one and this one, is equal to 180, you could, and you should, use theta to represent this angle and 180 minus theta to represent this one. Which means that by applying the cosine rule in both of these triangles, we get 64 equals 25 plus x squared minus 2 times 5 times x times the cosine of the angle in between the sides 5 and x, so cosine of theta. And for the second triangle over here, we have 36 equals 5 squared plus x squared as well, minus 2 times 5 times x times the cosine of 180 minus theta. Now, knowing that cosine of 180 minus theta is equal to negative cosine of theta, we could rewrite the second equation as such. 36 equals 25 plus x squared plus 2 times 5 times x times cosine of theta. And right now we can add these two equations and get rid of the 10x cosine of theta. And this gives us 100 equals 50 plus 2x squared, meaning 2x squared equals 50 and x equals 5 in the next step here. And that is it. Let's jump to the next exercise. All right, so exercise number 4, the longest one in this list. Let's take it slow so we get it, so we get every step of this exercise. So here's the scenario. Long story short, you're escaping a zombie attack And in order to escape, you enter a dark room. You suddenly notice that in that room there are 9 other people. So you and other 9. You're stuck inside, you see a light switch, you turn it on. Now, given that in this apocalyptic scenario, there's a 19% chance of someone having become a zombie. And by the way, you're not a zombie, don't worry. What is the probability that from those 9 in the room, at most 3 of them are zombies? Now, this is a typical binomial distribution. There are 2 possible outcomes, which are zombie and not zombie. The probability of success, which by the way is 0.19, the probability of being a zombie. I wouldn't consider that as success, but we can use that rationale. It doesn't change, the probability is 0.19 and that's it. And also the events are independent. Whoever got the virus and that's it. Now, if you call capital X, which is your discrete random variable, the number of zombies out of those 9, and knowing that this is a binomial distribution with number of trials 9 and probability of success 0.19, what you're actually trying to find is the probability of X being less than or equal to 3, at most 3, so it can be 3 or less. This is approximately 0.927 rounded to 3 significant figures. Now let's say that 3 of those people, they are zombies. You found a suitcase with 5 vaccines against this disease and you're willing to try it in these zombies. The label reads, the efficacy is 52%. Some assumptions for this exercise. You can tell whoever's a zombie. If you need, you can give zombies more than 1 shot, and also you can instantly tell whether the shot worked, meaning they suddenly stop becoming zombies. So they're not zombies anymore. They look like normal people. Now, what is the probability that you're able to cure every zombie with the 5 available shots? Well, from these 5 shots, at least 3 of them, they have to work. And we have a different discrete random variable now, which we're going to call capital Y. So capital Y is the number of shots that work out of those 5. We also have a binomial distribution with n equal to 5 and the probability of success 0.52. We want to know what is the probability of Y being greater than or equal to 3, which by the way, if you're using a TI-84, you might want to do 1 minus P of Y less than or equal to 2. So this gives you approximately 0.537. Now on to the hardest question. How many shots would there need to be in the briefcase in order for the probability of all 3 zombies getting cured to be at least 99%? Well, the probability of curing every zombie, all of 3 zombies, if we have only 5 shots, we just calculated that, it's 53.7%. It makes sense that having more shots would increase the probability of curing everybody, of course. So the question is, how many shots do we need in order to raise that probability to 99% or more? To define a new discrete random variable, which is the number of shots that work, but right now it's out of n. And we're going to calculate n. Our W is also a binomial distribution, n, 0.52. And we will like the probability of W being greater than or equal to 3 to be at least 99%, so 0.99 or more. Which, by the way, means that W being less than or equal to 2 should be less than 0.01. Now you could definitely guess and check and try a few numbers for n and check the results in your calculator until you get something which is less than 0.01, or you could create a table to do just that. And if you do so, you are going to notice that for n equals 12, the probability of W being less than or equal to 2 is 0.0137, which is not quite there. Now for n equals 13, we have 0.0077. Therefore, the briefcase should contain at least 13 shots. Alright, so last question of the list, exercise number 5, one that involves kinematics. Mr. Galileo bought a remote control car from his son Isaac, and as they turned it on, they were able to plot the velocity of this car in some way, don't ask me, which is represented by this curve. Now this is 8 seconds and we have a number of points here from A to G. Now referencing these points from A to G, we need to find where the car is at rest. What does it mean to be at rest? Well, the velocity is equal to 0. In that case, the graph should either be crossing or touching the t-axis, which means, in this case, points A, C, E, and also G. Question number 2. The car is neither accelerating nor decelerating. That means that the acceleration is 0, which means that the derivative of the velocity is 0, which means from this graph that the tangents to the velocity curve, they are flat, meaning they are horizontal. So in this case, we're talking about points B, D, E, F, and also G. Now do notice that in all of these cases, the derivative, which can be represented by the slope of the tangent line, they're all equal to 0. Last question, the car changes direction. An object changes direction when its velocity goes from positive to negative or from negative to positive, which in this case can be represented or is represented by points C and also G. Do notice that E is not a solution, it's not an answer because, well, the velocity before E and after E, they are both negative. So this does not represent a point or an instant where the car changes direction. Now, Mr. Galileo, being the smart guy that he is, he was able to come up with a model for this curve, and there it is. So the velocity can be represented by this function from 0 to 8. If we want to find the displacement, which is, by the way, not the same thing as the distance traveled, we need to integrate from 0 to 8, in this case, the function velocity with respect to time, which you should do using your GDC. So from 0 to 8, you plug in this function, and you get approximately negative 21.4 rounded to 3 significant figures meters. Now, is it possible for the displacement to be negative? Well, if the object ended its movement where the axis of displacement is negative, which means if it's oriented to the right, he finishes on the left, then yes, it's completely possible for the displacement to be negative. We're actually going to draw a motion diagram in the next exercise, and that is going to be very clear. Now, why do we need to draw a motion diagram to find the maximum distance between the car and the origin during that interval? Well, it's easier to see if you do so, and it's easier to explain also if we do so. Now, let's suppose that this object starts at the origin, which is exactly the case over here. Now, if this is the origin, which is point A, by the way, this is where the object or the car starts to move. As we go from point A to point C, the displacement, which is positive, which by the way is the area under this curve, will make this object go to the positive orientation of this axis right here, which means that he's going to do this. He's going to go to point C. Now from C to E, the area which represents the displacement, it is negative, meaning that he's going to go according to this orientation to the left now. Now this is point E, and then he goes even further to the left, and this is point G, and then we have this last area, which is t equals 8. Now I'm just going to label 8 over here. Now it looks like he's the furthest away from the origin at point G, but let's make sure that that's the case. Remember that this is the function of velocity, which means that we have t-intercept at 1, 4, and 7. How do we know that? Well, if you take this function and make it equal to 0, and at 0, by the way, if you make this function equal to 0, that's exactly what you find as solutions, t equals 0, 1, 4, and 7. So points A, C, E, and G, they are respectively 0, 1, 4, and 7. And if you want to find this area number 1 or displacement number 1, you just need to integrate v of t from 0 to 1, which gives you 11.45. So point C is at precisely 11.45 meters from the origin. And now we have this S2, which is the integral from 1 to 4 of v of t dt, which is negative 31.09. Now from here, he goes 31.09 to the left, which means that he is at 19.6 to the left of the origin. We just added negative 31.09 to 11.45, keeping the sign, so that's why we got negative 19.6. So if you want to indicate this as negative, you can as well. Now this area over here, which is approximately 5.57, meaning that we're going to go an extra 5.57 to the left. So this is negative 25.2. And then we go a tiny bit to the right, more precisely 3.85 approximately, which means that when t is equal to 8, we're at 21.4 approximately. Now, right now, we can address the question, which is, what is the maximum distance between the car and the origin during that interval? Well, it happens at g, which is when t is equal to 7, and the maximum distance from the origin that this object reaches is 25.2 meters. All right, so that's a wrap for week number 2. Hopefully you enjoyed the exercises, the challenges that you faced there. If you haven't downloaded it yet, you probably did because you were working on the exercise list. But if you want to find the PDF for this exercise list and also for other weeks, you can find them in the description of this video. And I'll see you next week.